Hello, my fellow chemists. And in this video, we're going to take a look at dosage. We'll go over the basic concepts of dosage, and then we'll do a couple relatively simple dosage conversion problems. This video is labeled as a basic video because there's really no concepts or terms that we're going to go over in here where you need to have any background information to understand it. So let's get started. It says, in dosage problems, you are given an amount of drug needed per weight of a person. And an example, I have several examples of dosages hidden here. So the first one is 5 milligrams per kilogram. There's two terms there. First one is the 5 milligrams. This is mass of drug. And then the second one is per kilogram. That is mass of person. Now, none of the problems are going to say that it's 5 milligrams of drug per kilogram of person. You just need to know that that first term is drug and the second term is person. You also want to think of this per as just meaning divided by. So if we were to rewrite that 5 milligrams per kilogram, it would look like this: 5 milligrams per kilogram. If there's no number there, you just put a 1 in there. Put your parentheses around. And then this dosage can then be used as a conversion factor to convert back and forth between the mass of the person and the mass of how much drug that person would take. Again, this top term up here, that's the mass of the drug. And this bottom term down here is the mass of the person or the patient. So it's actually going to be very important here when we do dosage problems. Not only do you have to label all of your terms, but you need to label them even more specifically. So if you're labeling a mass unit, you don't want to just know that it's 5 milligrams. You want to know, was that 5 milligrams of a person or 5 milligrams of your drug? Is it 1 kilogram of a person or is it 1 kilogram of a drug? So often you will see me in dosage problems, not only just labeling it as milligrams or kilograms, but labeling it as milligrams of drug or kilograms of person. I have seen dozens of students make the mistake where they get confused what mass unit is the drug and what mass unit is the person, and then they start confusing them. So you want to kind of keep them labeled throughout the entire problem. So if we again take a look at this first one, it says 5 milligrams per kilogram. Really, all that means is 5 milligrams of drug per every 1 kilogram of the patient, however much the patient weighs. Now, for dosages, you can have them in any units. I mean, if we take a look at another example down here, 12 grams per pound. So now the drug is in grams and the weight of the person or the patient is in pounds. You can have any units that you want. The second unit is always the person or the patient, and the first number or unit is always the drug. So if we were to rewrite this second one, it would be 12 grams per pound. Again, put your parentheses around. And this is 12 grams, that's the drug. And this is 1 pound, that's the person. And then we're going to be using these conversion factors, these dosages, as a conversion factor to convert back and forth between mass of drug and mass of person. So let's take a look at a couple of sample problems. Those are the best ways to learn how to do these, just to go through a couple sample problems and see how dosages can actually be used and how they are used in problems. So the first problem that we have here states, if the dosage of a particular drug is 35 milligrams per kilogram, how many milligrams of the drug would a 200 kilogram person take? Now that the problems that we're looking at are starting to get a little bit bigger and have a little bit more information in them, you always want to write down all of your terms first and just kind of see what you're given and then find out what you're being asked to solve for. One of the biggest questions I always have from students is I read problems and I just have no idea where to start. Best place to start is let's write down the information that we're given. We're given 35 milligrams per kilogram. Okay, and then you got to say, well, what is that? All right, that's the dosage. And I'm going to say it's 35 milligrams of the drug and 1 kilogram for the person so that I don't get them mixed up. Any other information that we're given in the problem, we're told that the person weighs 200 kilograms. So we're also given 200 kilograms. Was that 200 kilograms of drug or 200 kilograms of the person? It tells us in the problem that's the person. And then we need to find out, well, what are we being asked to solve for? So the question is saying if the dosage is 35 milligrams per kilogram, how many milligrams of drug? How many milligrams of drug? So we want to find our final answer is going to be milligrams of drug. That's what we're being asked to solve for. So now now that we have all of our terms, you want to kind of take a look at how can I get or how can I isolate milligrams of drug here? Because that's what I'm being asked to find in the problem, milligrams of drug. I want all of my other units to cancel out except for milligrams of drug. Well, what other units do I have? I have kilograms of person here, and I have kilograms of person here. Well, it's both mass units, and they're both in the same unit, kilograms, and they're both for person. Neither one of them is for drug. So we can use the factor label method to cancel out these kilograms, and then we'll be left with the only unit left will be this milligrams of drug, and that will be our answer. So to set this problem up, anytime that you have two or more terms, and one of those terms has one unit on it, like this 200 grams here, that only has one unit on it, kilograms, and then you have another term that has two units on it, like this 35 milligrams per 1 kilogram that has two units, milligrams and kilograms. Always start off by writing the unit that just has one term on it, because that'll force you to work from left to right. And that's the normal way that we read and write, so it'll make it easier for you. So the first thing that we're going to do is we're going to write down, we have 200 kilograms. And I'm just going to put under here in parentheses P for person, just so we know that's for the person. And now we're going to use the dosage as a conversion factor. And we want the mass of the person to cancel out, so we'll put kilograms on the bottom because that's what the person is. That's from this up here. And then we want to be left with the mass of the drug, which is in milligrams. I'll put a little D above it so we know that's drug. And that says it's drug because it's from up here. And that's 35 milligrams of drug for every 1 kilogram of person. All right, well, now we have the problem set up so that kilograms and kilograms of person cancels out with kilograms of person, and the only unit that's going to be left is milligrams of drug. And guess what? That's what we're being asked to solve for. So now all we have to do is, just like with any other factor label problem, is multiply across and divide up. We take the 200 kilograms of the person, multiply it by 35, and then divide by 1. We'll come out with 700 milligrams. And what is it milligrams of? I'll just put in parentheses here, drug. And the question wants to know how much drug would the person take in milligrams? Well, they would take 700 milligrams of drug. Okay, so this is a relatively simple problem because it's really only one step long, but it is a good example to show you just the basics of how to do a dosage problem and convert a person's mass into the amount of drug that they need to take based on the specific dosage for that drug. So let's take a look at another problem that's just slightly more complicated, but a little bit more realistic for what you would see if you're working as a healthcare provider in the United States. And the reason why I say this one's a little bit more realistic is because the initial mass of the person is not going to be given in kilograms, it's going to be given in pounds. Because most people in the United States, they weigh themselves in pounds as opposed to kilograms. So this is pretty common for what you would see as a dosage conversion problem in the United States. So let's take a look at this second problem here. So this problem says, if the dosage of a particular drug is 4 milligrams per kilogram, how many milligrams of drug would a 160-pound person take? Notice the difference here is you're being given the mass of the person in pounds as opposed to kilograms, which is pretty much more common than seeing their mass given in kilograms, at least for in the United States. So again, let's write down the information we're being given and then write down what we're being asked to find and then kind of map out a way to solve the problem. So we're given a dosage and it tells us what the dosage is right here. It tells us the dosage is 4 milligrams per kilogram. So we have 4 milligrams per kilogram. Okay. And what this is 4 milligrams of drug and 1 kilogram per the person. Okay. And then we're also given the mass of the person as 160 pounds, and this is person. I've seen people get mixed up before where they think this is massive drug, and they see that it wants to. I've taught courses with dosages in it for over 20 years. I've seen students where they'll say, okay, well, what is the problem asking for? All right, well, let's see what the problem's asking for. It wants to know how many milligrams of drug. Okay, so we need to find milligrams of drug. That's what we're looking for. I've had students before, they would take this 160 pounds because they didn't realize it was the mass of the person, and they would convert pounds into kilograms, kilograms into grams, and then grams into milligrams, and they would think that's the answer. Well, what they did was they just converted this person's mass into milligrams. That's not what we're looking for. We want milligrams of drug, not milligrams of the patient. So that's why for these dosage problems, you have to be very careful to make sure, have everything labeled. This is mass of person, mass of drug, and you're looking for mass of drug. It is very common for beginner students to just take this mass of the person in pounds, convert it into kilograms, and then go from kilograms to grams and grams to milligrams. And they don't even use the dosage, and they get the problem completely wrong. So make sure that you don't do that, and make sure that you label everything. It'll make the problem much easier for you to do. So now, again, the problem is asking us how many milligrams of drug. So we want everything else to cancel out except for milligrams of drug. Well, we have mass of person here and mass of person here. So we can have those two masses cancel out of the person. And then the only thing you'll be left with is mass of drug. The only problem is the mass of the person in the dosage is in kilograms, and the mass that we're given for the person is in pounds. So the first thing that we have to do is convert this 160 pounds into kilograms, and then we can use that to cancel the mass of the person out and be left with the mass of just the drug. So this is going to be a two-step problem. So let's first convert the 160 pounds. I'm going to put it under the parentheses here, P for person. That 160 pounds, we're going to convert that person's weight into kilograms. Okay, so if we have pounds down here and kilograms up here so that the pounds will cancel out. And we know that it's 2.2 pounds for every 1 kilogram. So now we're set up so that pounds and pounds cancels out. Then we just multiply across and divide up. And when we do that, we find that a 160-pound person will weigh 72.7 kilograms. And I'm going to put underneath of this again, P, so that we know this is not the mass of the drug. That's the mass of the person. Now that we have the mass of the person in kilograms and our dosages in kilograms for the person part of it there, we're now going to use the dosage to convert from mass of person into mass of drug. So we'll put kilograms on the bottom, and we'll put milligrams on the top. And I'll put up here little d, so this is milligrams of drug, and I'll put down here little p, so we know that's kilograms a person. And we're told that it's 4 milligrams of drug for every 1 kilogram of person. Kilograms of person cancels out. Now we just multiply across and divide up. And when we do that, if we take 72.7 kilograms and multiply it by 4 and then divide by 1, we get 290.8 milligrams. And it's milligrams of drug, because that's the only unit that's left. And that's what we're being asked to solve for in this problem, how many milligrams of drug. All right, well, those were two sample problems of solving for dosages. The first one used the person's mass in kilograms, and the second one used the person's mass in pounds. And the second one's a little bit more realistic for what you would see. Uh, in the next video, we're going to take a look at some more dosage problems, but they're going to be more complex dosage problems. And they're going to look at the dosages of liquid drugs where you have to bring densities of the drugs in. And then they also just are going to have more steps in them in general. So that's all I wanted to show you in this video. I hope you learned something, and I'll see you in the next lesson.